Welcome back to Speller Tutorial Services. Today we're going to work on a word problem. In this word problem we're going to end up creating a quadratic equation, and with that quadratic equation we're going to use principles we've learned about maximum and minimum, in particular minimum for this problem to solve it. So let's begin. We need to find two positive numbers whose sum is 100 and the sum of whose squares is a minimum. So let's begin by defining the first number and the second number. Alright, the first number we're going to define as x, and the second number will be defined as 100 minus x. We come to the expression 100 minus x by doing a quick little example. Let's say that our first number is 25. So our second number would have to be 100 minus 25. Alright, and we know that 100 minus 25 is 75. And if we go one step further, we see that 25 plus 75 is 100. So at this point we can rest assured that our expressions here are correct. They do model what the first part of this problem asked for, where two positive numbers whose sum is 100. Now we have to move on to the second part. And the second part says, and the sum of whose squares is a minimum. So let's begin by just calling this a function, f of x. We know the first number is x, so we need to square it. And we need to add that to the square of the second number, where the second number is 100 minus x, and we also have to square that. Our next step is to FOIL and simplify this function. So we have x squared plus 100 minus x times 100 minus x. Now we're going to FOIL to get this to make this even simpler. So 100 times 100 to give me 10,000. 100 times negative x to give me a negative 100x. Negative x times 100 to give me another negative 100x. And then negative x times negative x to give me a positive x squared. At this point I'm going to combine like terms. I end up with 2x squared minus 200x plus 10,000. And as I said earlier, this should be 2x squared. And as I said earlier, this problem is a quadratic, and we see that because this function here is has a degree of 2. Next thing I want to get into before we continue solving it, it said that we're looking for a minimum. Because we have a positive coefficient in front of this x squared term, we know that this is going to form a parabola that opens upward. And with it opening upward, we know that our vertex here would in fact be the minimum that they're talking about in this particular problem. So the first thing to do, let's make this a little bit simpler by factoring out a 2 from all of our terms. So here we're left with 2 times x squared minus 100x, and then that 10,000, take half of that to end up with 5,000. Alright, being that we know that the minimum here is the vertex, we can fall back on our expressions where for x it would be negative b over 2a, and we know that y would be f of negative b over 2a, where we take the expression 2a and we substitute that or make that the input into function f. So let's do that. In this particular problem, we know that a will be 1 because that's understood to be the coefficient of our x squared term. We know that b to be negative 100 because that's the coefficient of our x term. And if we needed c would be the value of 5,000. All right, now let's go ahead and scroll down some so we can get to this vertex here. So let's use x is equal to, like I said, negative b. So that's going to be negative times negative 100. And then we're going to divide that by 2a. In this case, 2 is what's given and a is 1. So we end up with negative times a negative to give me a positive 100. 2 times 1 to give me 2. And then you see that we end up dividing by 2 to give me an x value of 50. All right, let's scroll back up. If x is 50, then 100 minus x would also be 50. So here we found that the two integers, or the two positive numbers would be 50 and 50. Alright, that sums it up for this video from Speller Tutorial Services. Please friend us on Facebook and also subscribe to our YouTube channel, both found under the same name. And as always, thank you again for watching.